Hey everyone. Uh, think I'm live. Trying to set. Somehow I'm not being shown as. Can someone confirm if I'm live or not? Okay. Yep. Cool. I can see my. Uh, okay. Let me know if you guys can hear me properly, if I'm audible, or if there are some audio issues on your end. And we'll get started. Right. So let me know how were the questions. Did you like the questions? Did you not like the questions? You see what? Thank you, Shubham. Thank you. Uh, thank you, Gurjit. Saptarshi. Cool. So how were the questions overall? Did you like the questions? If you face some difficulty, or did you not like the questions? Let me know right now. How were the questions overall? Yes, you're audible. Thank you, Saptarshi. Thank you, everyone. Fair enough. Okay, fair enough. Okay, so what we'll do is we'll start with the problems without wasting a lot of time. Right. Good. Okay. Thanks, Riaj. So let's start with the first problem. Good questions. Okay. So you are given a string. Test case w. Okay, we'll see. So you are given a string str of length n. You want to choose a non-zero integer k such that you can perform the following operation. Take a prefix of the string, right? Take a prefix of the string of length k and append the reverse to itself. Your task is to find the lexicographically smallest string that you can get. Okay, so the question is, you are given a string, right? You are given a string of length n. You have to take a integer k. You have to take some integer k where k is definitely less than n. What you have to do is you have to take up the prefix of length k from the string. So you have the string, you have to take the prefix of length k from the string. Then you generate a new string with this prefix and appended with the reverse of the prefix, right? So the prefix and the reverse of the prefix will be appended. Your task is to generate the lexicographically smallest string that you can get, right? And k is not fixed. K is something that you have to determine what should be the ideal value of k, right? So that is the question. For example, B, V, D, F, N, D, K, N. In this, the output should be BB. That is, if K equals to 1, you will get the answer. That is, you will just take the prefix B. And what is the reverse of B? B only. So B plus B is BB. So that, and if you take two elements, like if you take K equals to 2, in that case, you have BV, right? So in that case, it will become BV, BB. So that is lexicographically greater than BB, right? BB is lexicographically smaller. Similarly, if you take three of them, again it will be lexicographically greater. So the output, the best possible answer will be BB. Like taking just k equals to 1, so you will have BB. Okay, so that's the first one. Second one is CAST. Now in this case, if you just take C, if you take k equals to 1, you will get CC. If you take k equals to 2, you take this prefix Ca and you append it with the reverse of it, that is AC. So CAAC. If you take k equals to 3, CAS and SAC, CAS SAC, right? And like that. So the best possible solution will be CAAC. This will be lexicographically smaller than CC as well, right? Just CC, it is lexicographically smaller than CAAC. Yes. So this is given to us. How do we solve this? It's pretty simple. Like if you have already got the idea, you should have already got the idea, right? The idea is you want to generate the lexicographically smallest, right? You want to generate the lexicographically smallest. What do? The idea is, let's say you have some you have the string here, let's say CASP, right? CASP. The idea is, first of all, it's always better. What is better? You have to identify what is better if you want to take it. Like, initially k equals to 1 you have, but should you go to from k equals to 1, should you go to k equals to 2? Yes, you can go to k equals to 2. Why? Because you have a decreasing character here. With C you have a decreasing character here, so as long as you have a decreasing character, it is better for you to go. Why? Just think about it again. D C B A F P K, let's say something like this is there. So in this case, if you see, it is better to take DD. It is even better if you take DC, because you will be getting DCCD, which is lexicographically smaller than DD. It is even better if you take DCB, right? Because you will be getting DCB, BCD. This is lexicographically smaller than DCCD. Why is this lexicographically smaller? I think you understand that. Just compare character by character. So DD is same, CC is same, C is here, B is here. So this is lexicographically smaller, right? So similarly, DCBA, taking DCBA is better because you will be getting DCBA, ABC, right? So that's why it is better. So the idea is, as long as you have you have to take, you can form the take the prefix as long as there is decreasing characters, right? Decreasing character towards the right. So for example, D then C B A, this is a decreasing set of characters, so you can take them together. If let's say there was D Q B A, right? In that case, you cannot take DQBA because DQ is worse than DD. DQ is worse than DD. So you cannot take DQBA. So as long as it is decreasing only, then you can take. So pretty simple logic. I hope that makes sense, right? Let's quickly write the code for this. Let me know if you have some doubts on this. So what we'll do is string answer, or let's call it temporary, equals to this. For int I equals to 0, I less than str dot size I plus plus, right? Let's take start from 1, and tmp equals to this, and tmp plus equals to str0, right? So str dot size I plus plus, if stri is less than stri minus 1, if stri is less than stri minus 1, in that case only we'll take. So tmp plus equals to stri, or else the first time this is not satisfied, we'll just break, right? So return tmp plus tmp. So return tmp plus tmp, sorry, we have to reverse as well. So string answer tmp, reverse tmp dot begin, will reverse this tmp dot end, and return answer plus tmp. Okay, so that should be it. Let's try to run this. We are getting nbbn, which is true, so let's submit this. I hope this is clear with everyone. Like, pretty simple question. um the idea is pretty simple. Like, if you want lexicography smallest, you will have to go for a decreasing sequence, right? Because again, like, if you choose anything that is greater than that, that prefix becomes greater than, like, if you don't take it. So that's the idea. Cool. Okay, so let's I hope there is no doubts on this. Let's go to the next problem. So this is called BST maximum difference. The problem statement is, for string WN, okay, let's take that string as well. The string that Gurjit is talking about, let's take that, right? So W, okay, it's pretty big. Sorry. So WNN RU A RUAAU. Okay, there are some things, but again, like we'll find that anyways. It ends here. So W, what we'll take is WNN, right? NN is okay, and after that R, right? So R is WNNR. Okay, should we take NN, right? And should we take NNR, right? If we think about it, let's see. So WN, right? WN NW, and if we take WNN, so it will become WNN NNW. So in fact, it is better. In fact, I think it is better to take WNN because we are here. We have W. Here we have N. Right. So it is in fact better to take N. Uh, Interesting. Okay. So WNN WNN NNW. Yep. And if we take R after this, OPQR. We'll not take R because R is greater, right? R is greater than N, MNOPQR. So R is greater than N, so we'll not take R definitely, but we can either take WN or WNN, right? So I think it's better to take WNN because again, like you, if you compare lexicographically, the WNN becomes smaller. W, yep, W is smaller because here we have W, here we have N, right? So I think yeah, like we have to take the condition to be less than equal to, not less than. That's true. Let's see what is the output for our question. Also, that is substring can be reversed and is lexically smallest. Yes, yes. WNN. I think it is smaller than WNN RUAA. No, WNN RUAA will that. Okay, so I think you have understood this wrong, right? You do not append it with str, right? You do not append it with str. You take the prefix, whatever prefix you get, with that prefix you attach the reversed string. With that prefix you attach the reverse string, right? You do not attach with str. So what you have done here is you have the string WNNRUAOP. You have attached, you have taken the prefix WNN. So you have attached WNNRUAAURNN. Okay, you have taken that prefix. In fact, this is not lexicographically smaller, right? If you check this, WNNR, R is not smaller than N, R is larger than N, right? PQR, ABCD, N, MNO, PQR. So R is larger than N. So you cannot, when you compare between W and N, like just see the see this comparison, right? Just see this comparison. If you have a W and an R here, W N N R here, and after that R N N W, this will not be smaller than W N N N N W because you have R here, you have N here. You have R here, you have N here, right? So this is not smaller. So you will take WN or WNN, but ideally you should take WNN, right? You should ideally take WNN, not WN, because even WNN is giving a smaller result than WN, right? So we'll see. Like I think the test cases are weak. This should not have passed, but again, like let's just test it out once quickly. So the string will be WNN RUAOP. uh, So yes, WNNW, and the output is also giving WNNW, which should not be true. You should have taken, it should be WNN NNW. So it should be less than equal to. This one should have been less than equal to stri less than equal to stri minus 1. Then you can take it. Because that makes sense, right? You will take a lesser value. So the comparison, so again, like you repeat it, right? Whenever you repeat this thing, so here as it is clear, right? WN, if you take WN, you have WNNW versus W, you take two N's, so WNN, and again the reverse of that NNW. So this, here you have the difference, right? So it is better to take repeating ones. So I think the this will fail, but actually this question is wrong. Then we should have taken like that. Yeah, mmifh, uh, mmifh. We are given In fact, this is true for at least, right? So this is not very simple if you think about it. So if you take 2m, right, and after that, okay, after that you have hmm, right, okay. So this will not be less than equal to definitely, but it will not be less than as well, because this will fail for conditions like this. It will fail for conditions like this. So ideally, what should we do if we have some repeating characters, right? If we have some repeating characters, we can check like it's so again, like let's say you have just n and n, and after that a. In this case, it is better to just take one n, right, and you have nn. But if you take two n's, you will have nn, which is not better than nn, it is worse than nn. Similarly, if you take the entire thing, you will have nn a a n. Again, this is worse than nn, right? So you have to take it a bit carefully, like when the repetition, right, when the repetition is at the first. So the idea will be um, okay, the idea will be something like this, that uh, you repeat it. So you take a smaller one. Hmm. So the idea will be you have to compare, right? What you have to do is WNN RR AO, let's say something like this is there. Okay, you have WNN here, right? And you're comparing with WN, like should you take the second n as well? In fact, here, if you see, it has been, there's a decreasing element, and after that there and if you should take, let's say there is another thing called WNNN, should you take this as well? AA is possible. It will exclude smallest string and smallest strength string. Is there any yes, there is a relationship. So if two strings are same, right, if the two strings, if you compare two strings and both of the strings have similar characters, right, one string is a prefix of another string, then the smaller string is considered to be lexicographically smallest, right? So basically, if you have BB and if you have BBBB, so BBBB will be lexicographically smaller than BB, right? So in our case, it will be WNN. And let's also think about another case called WNNN, right? Should you take 3n's or 2n's? Let's understand each of them. So WN, if you take 2n's, right? If you take 1n, so WN, uh, it will be NW. If you take 2n's, WNN, NNW. Here you have the difference. If you take 3n's, W, NNN, NNNW. NNNW. Okay. So you can, it is even better, like which one is better now? This one is better, right? If you see this lexicography comparison, this one is better. So if you have something, right, if you have a smaller element at first, if you have a smaller element like W at first, after that you have a series of similar elements, right? In that case, you should take this all the series of similar elements. But once you take a similar series of similar element, after that you cannot take any other element regardless it is smaller. Like for example, after that a is there, right? So let's say after that WNN a is there. So in that case, you will have WNN a, WNN a, a, NNW. Is it better? WNN a, AAW. Is it better than W? In fact, this is also better, right? WNNW. And this is better than WNN NNW. So in fact, this is also better. So provided, I think the idea will be that provided you have some character in front, you have some lesser character in front, stri pimp plus equals to stri, ch equals to stri, while ch minus a, ch minus a greater than stri minus a less than I less than n. Okay. W n and w is correct. Why is w n and w correct? The output should be w n and w, which is lexicographically smaller. W n and w or w n n n and w. Which one is lexicographically smaller out of these? Check character by character. You have ww. After that you have nn. After that you have nn again, and after that you have w here. You have n here. So you have w and n here. So this will not be correct, right? The second one is lexicographically smaller. Correct me if I'm wrong. W n n n n w will be lexicographically smaller than w n n w, because there is n here, there is w here. So this should be lexicographically smaller, right? So only when it is a prefix, right? If it would have been like this w n n w n w something like this, in that case it would have been greater than w n n w, because w n n w is a prefix of this completely and it is smaller in size. So that's why this is lexicographically greater. But when there is when there is like when the characters are not same at some place, you have to compare whether the character, like which character is smaller, like n is smaller. Length does not matter. So it, once we compare character by character, if there is a difference in one of the characters of the two strings, in that case whichever has the lower character value, that will get a preference. Otherwise, if all the characters are same, right, if all the characters here are available here as well in the same order, in that case the length will matter. Like this is smaller, so this will get a preference. But that's not the case. W is here, we have n here, so w n and w should be the case. So I think the idea is if you have a greater character, if there is one, at least if there is one difference, right? So if there is something like, if you have a starting, like if you have starting only like bb, after that a something like this, in that case it is better to take bb, because you will have end up with bb and after that something. So if there is a repetition in the starting element itself, it is not better. But after that, so you will have to note that after the first element, let's say you have c, and after that you have b, and after that you have b, after that you have a. In this case it is better to take c b b a altogether, because c, just c b b c, or you have c b b b b c, or you have c b b c b b a b b c. Which one is better? Just see this part. A is better, right? A is better, right? So you should take this one instead of that one, right? So what we can do here is, yeah, I think that should work, right? So the idea is simple. First time, if the first character is repeated, right, for the first character, if it is repeated, you do not consider repetitions. You do not consider repetitions. For example, bb is repeated here, you will just take bb. That is better. If the first character, if for the first character there is, like after the first character, like after c, if there is repetition, you should take the repetition as well, right? So although I think the question is wrong, like the solution is wrong, because here also it is giving w that thing. But yeah, like the ideal solution should be something like this. I'm not sure if the test cases are wrong as well. So bool is greater seen equals to false. So if stri less than stri temp plus equals to stri is greater seen equals to true. Else if stri equals to stri minus 1 and is greater seen, right? So you have seen a greater character is greater seen. In that case you will take, right? You have seen a greater character before, so you will take this. So temp plus equals to s of str of I. Else you will break. So let's actually run this only mmifh, right? Let's run this mmifh, and after that we'll take wn and that part. So let's run this. This should give us only. So this is giving that's true. Let's take another example. In this example, like we have cbba. In this case, cbba should be smaller, right? Let's see what is the output. So we are getting cbba, and here it is output is cbbz, which is wrong, right? Because a and c, just see a and c, here there is a mismatch. So cbbabc, that should be the correct. So I think this will not work, this will give a wrong answer maybe, but yeah, like this is the idea. Yeah, here they're giving xffx, but if you see, this one is better than xffx, right? This one is better than xffx, lexicographically smaller than xffx. So the solution is wrong, right? Thank you for the test case actually. I think it was Gurjit, right? Gurjit, thank you for the test case, it was a nice observation. So this solution is wrong, but it should have been xffx. So the idea is, again, you just have to maintain if you have seen a greater element before it, otherwise it's not better to take a repetition. If you have seen a greater element, in that case, if there is a repetition of character, then you will take that as well, provided you have seen a greater element before this. WNNRUAOP. Yes, WNNR, it should take WNN, right? WNNRUAOP. So it should give the correct answer only right now. Yeah, WNN NNW. That should be the answer, right? R will not be taken because R is greater than N, right? R is greater than N. So R will not be taken. But just think about it. If R comes here, it will not be taken. But WNNW should be the answer. Got it? Okay. Uh, Good catch. So let's go to this one. By the way, to see that the previous is wrong, so make sure you do it correctly as well once. Okay. So BST, maximum difference, right? So you are given a binary search tree and a target value. You must find the maximum difference between the sum of the node data from root to the target and from target to the child leaf node. Target exclusive. Initially you are at the root node. If the target node is not present, you have to return -1. We should stop if we found similar character, same character. Just think about it when you will not stop, right? Just think about this example. 1 minute programming, think about this example. CBBA. Should you stop in this case? Should you just take CB, or CBBA is in fact much better? Just write it down and check like which one is better, which lexicographically is smaller. I think this makes sense, right? Lexicographically CB, this one is lexicographically smaller than CBBC because there is A here, there is C here, right? So this one should be smaller. Okay. So you have 25, so you have 25, you have 20, you have 35, 15, 22, 30, 45, 32. So you are given 20, right? So again, the question is, you are given a target, you have to find what is the, you have to find what is the maximum difference possible. I think maximum difference possible from the, between the sum of the nodes that are from the root to the target, that is from root to target only 25 is there, 20 is the target, right? Excluding the target definitely. So 25 is there, and a leaf node within the subtree of the target up, and the sum of the nodes in the path of a leaf tree in the subtree of the target. So in the leaf tree, what in the leaf, what are the leaf parts of the leaves are there? 15 and 22. So 15 is a lower one, so we will just take 15, right? Because it is lower one, and we should take the maximum difference. So it is pretty simple question, right? The question is pretty simple, and let's just quickly understand one more time, like what does it tell, and then we can go into the code for this. So we are given a binary search tree. This is important. We are given a binary search tree. Let's say we have 20 here, we have 10 here, we have 25 here, we have 22 here, we have 27 here, we have 30 here, we have 24 here, 25 right side, 26 here. Okay, 22. Yeah, let's say the target is 26, 30. Yeah, 22, that should be okay. So target, let's say, is 27, right? Or 25, let's say, is the target. So this is the target node. So what is the sum of the elements from the root? From the root to the target. So what is the path from root to target? This is the path. So what is the element except target? 20 is only there. So 20 is only there minus. Now you have to maximize the difference. So your idea will be, if you want to maximize this value, you have to minimize this value minus something. So you want to maximize this entire thing. You want to maximize this entire thing. So you have to minimize this thing. This thing should be minimized. What is this thing? It is the maximum sum of the nodes in a path to one of the leaf nodes under 25. So what are the leaf nodes under 25? 22 is the one of the path is this one, 22. One path is 27, 26. One path is 27, 30. So what is the minimum out of them? The minimum out of them should be 22 only. So 22. So the output should be 20 minus 22. That is minus 2. This is the maximum possible value that you can get. Right. So the question is pretty simple and straightforward. What you have to do, you have to find the sum of the nodes in the path from 20 to 25. That is something, and it is a binary search tree. So for binary search tree, the searching becomes simpler. You will go only in one direction. After that, you just have to find the minimum path to a leaf, minimum sum path to a leaf in the subtree. Nothing else, right? So that is also pretty simple. You can do it easily using a DFS. So let's go ahead with the code and we'll see if there's some doubt there, right? So first of all, in the private section, we'll find a node star, find target, right? And we have a current node, the current node that we are at, and we are given a target. So we are finding the target, right? So now if current of data is equals to target, return current. Otherwise also, first of all, if current is null, current equals to null, in that case target is not there, so you will just return null. We can make the checks in the main method, right? If target is present on the right subtree of the root, then we need to find the max in right subtree. If target is present in the right subtree, yes, target is present in the right subtree, then we have to find the minimum. What is the minimum path in the till the root leaf node, right, in the right subtree? Please explain the test case. Sure. Let's take a better example. I think okay. So here, let's say you are given 35, right? Okay. Let's say you are given 35. Target is 35. So you are told what is the maximum difference between the sum of the node values from the root to the target, excluding the target. So what is the sum of the values of the node from the root to the target? What do we have? We have 25 and 35 only. So we have 25 and 35. Let's open up open board. Yeah. Okay, let's see. So we have 25, and from here we can come to 35. 35 is the target node, right? 35 is the target node. So what is the sum of the values in the path from 25 to 35? Only 25 is there, excluding 35 definitely. Now what do we want is 25 minus. We want to find the possible, like you want to go from 35, the target node, to one of the leaf nodes and find the sum of the paths. So let's say you go to 32. What path do you take? This one and this one. What is the sum of the nodes in the path? 30 plus 32. and here you can just go to 45 like this, so you have 45 as the sum. So either it will be 25 minus 30 plus 32, or it will be 25 minus 45. Which one will give the maximum value? Which one will give the maximum value? That will be the answer, right? Okay, so this one will be the answer. I hope it makes sense. And it is not given absolute difference, right? I don't think it is given absolute difference. Maximum difference between the sum of the node data of the root to target and from target to the child leaf node, right? So it is not given that you just have to find the absolute difference. Okay, so you have to minimize this value. This value is fixed from root to target. From root to target, this value is fixed. You want to maximize something, so you have some fixed value minus some variable quantity. This value is variable, this has multiple values, right? The path to the leaf node. So you want to minimize this thing, you want to minimize this thing, right? What if root equals to target? Fine, this will be 0, fixed value will be 0. You just have to minimize this part. If root equals to target, the fixed value will be 0. The sum of the path from root to target will be 0, nothing else. Okay, so let's try to write the code for this now. Current of data is equals to target, then return. Otherwise, if current of data is less than target, then it is on the right hand, it is on the right child. So return find target. Will continue a search in the right child. So current of right and target, else return find target, current of left and target. It is on the left child, right? So you have this. Now let's find this target, so node, and also you have to maintain the sum as well, right? Int sum equals to 0, let's say sum here is defined, and what you will do is sum plus equals to, and except this one, if you come here, then sum plus equals to current of data. Now node star target node equals to find target. We'll find the target, current and root and target, right? We'll find the target. Now if target node equals to null, right, target node equals to null, then it is not present, so we will return -1. We'll just return -1, right? Else we will return the minimum in the subtree, right? So void, or let's call it int dfs, node star current, we are doing a dfs here, node star current, and yeah so we want the minimum path value, so int minimum equals to, let's take a int max. So we'll go to the left subtree. If current of left is there, mn equals to min mn, and mn equals to, we'll just go to the left subtree, so dfs current of left. If right is there, current of right is there, mn equals to dfs a minimum of, we want the minimum, so minimum of mn, and dfs current of right. Here we are not comparing, with minimum, like which one is minimum, because minimum is initialized with int max, so definitely this one will be better anyways, right? So dfs current of right. Now if mn equals to int max, return int max, else return mn plus current of data, minimum plus current of data. Now we have this, so sum minus equals to dfs target node. So target node, what is the maximum sum in maximum sum path in minimum sum path in the subtree that we are finding with this dfs, dfs target node, and minus we have also added the value of the target node, so minus target, right? So that should be done and return sum, and here we should set sum to be 0. Yes, we should do that. So here we have done sum equals to 0, right? So this should be the code. Let's try to run this. Okay, we are getting expected output is -1. Oh yeah, so if int val equals to dfs target node, if val equals to int max, but this should have already returned -1, right? Target node, find target, and that sum equals to 0. Target node is also there. Val equals to int max. In that case, will if val equals to int max, we'll just return. That means there is nothing in the subtree, right? And that should also not be the case. Should not be. Uh, okay, if in mn equals to int max, then we should return current of data only, the current node's value. Otherwise, because there is nothing, like there is no left and right child, that's why it is giving int max. So we should just return the current of data. Otherwise, we should return mn plus current of data. So that should be it, right? So this should be removed. If it's target node, let's run this now. I think -1 is case is causing some problem. We'll see. Okay, expected output is also -1. Target is 2, 1, 3. Okay, got it. Cool. So this is working. So let's try to run this now. Yes. So this code is working, right? Pretty simple. Again, just to repeat again, we are finding the target node first in a binary search tree. Again, it's a binary search tree. So we can, like, we know that the left subtree is less than the values in the left subtree will be less than the current node value. The values on the right subtree will be greater than the current node value. So that's why we are searching on a binary search tree. This is straightforward. Like if it is less than target, then target should be on the right subtree. Otherwise, it should be on the left subtree. After that, we have written another function that will calculate the minimum sum path to a leaf node. For given a node, minimum sum path from that node to a leaf node, right? So what we are doing here, if current of left is there, we are going to current of left and finding the minimum sum path. If right is there, we are going to current of right and finding the minimum sum path. And after that, whatever, if the minimum is not there, if both left and right is not there, in that case we should just return the current node's value. Otherwise, we'll return minimum value plus current node of data, right? And so we are finding this target node. This sum is also calculated while in the path, while we go to the path. And if we are subtracting it from that, right, we are subtracting the minimum sum path from that. So that is the entire code. Okay, let's go to the last question. Yeah, let me just this for now. There is a forest represented by grid of n rows and m columns. At t equals to 0 second, some of the cells are fired. Every second, the fire spreads to the 4 adjacent cells. A man is stuck in the forest. In 1 second, he can move by one cell, right, left, up, or down. If he reaches the sides of or the corners of the grid, he will get saved, right? Your task is to find out if there is a path such that he can escape avoiding the fire. So the output is yes. Okay. The question is pretty simple, I think. Like, to understand, you are given a grid. Now some of the cells are fire, like you are putting up a fire in some of the cells. The fire is spreading by at a time, like by spreading by 1 second at a time. So basically in 1 second, if it is in this cell, it will spread out to the neighboring cells in 1 second, right? To the four adjacent cells. So it will be spreading in the four adjacent cells. Now he can move by one cell to the like it moves up, spreads to the four adjacent cells. Now there is a man as well at some coordinate. What he can do is he can also move to the four adjacent cells in 1 second. You have to find if he can escape, right? That is, if he can reach one of the corners or one of the sides, then he is safe. Basically the question demands that if the man can reach one of the sides or one of the corners at a time less than that the fire reaches that side or fire reaches that cell, right? If he can reach to a cell at a time that is less than the time required by a fire to reach that. So that is the question, right? If you think, see this, this and x. So here the man is here. In 1 second the man will come in this cell, and the fire spreads to this one, this cell and this cell, right? And thus the man is safe, right? Once he reaches here, in 1 second the man moves to the left cell and will be saved. Similarly here the output is no. Let's see why is this no. So all side is fire, right? So the man does not have a position to move from here. Like, there is fire already here, here as well, here as well, here as well. So the man cannot move, right? Okay, let's quickly like, again, this is also pretty simple and very similar to last week. We have already solved a question last week. I hope that you remember. Can anyone tell what we should use for this, how we should solve this? Can anyone tell? Can anyone tell how can we solve this? Similar to rat in a maze type problem. Not exactly rat in a maze problem, is different. It's a backtracking problem. So this is not exactly similar. Anyone can tell what can we use to solve this problem? BFS, yes, exactly. Right. So we had done a similar question in the last week as itself. So let's say the man is here, right? And the fire is here, here. What we can do is, the idea of this problem is, and also the fire, let's say, is here. The idea of this problem is that, first of all, you just have to find for every cell what is the time at which it will be burning, time at which it will burn. Let's call it Tij. Tij is the time at which the ij cell will burn. And also, let's say Mij is the time taken by man to reach ij. Yes, Mij is the time taken by the man to reach ij, and time at which it will burn is Tij. The task is to find if there is a cell at one of the four sides, at a side. Let's call it RC, such that MRC, that is the time taken by the man to reach RC, is less than that of TRC, the time taken by Fryer to reach RC. In that case, the man will be saved, right? So basically the question is, again, if there is a cell at one of these places, right? These are the points where the man can leave from. one of the cells from here, right? So if there is such a cell in these positions where the time taken by the fire to reach, it should be less than, it should be greater than the time taken by the man to reach. In that case the man will get saved, otherwise the man will not be saved. Now how do we calculate Tij? We can use a BFS, because again, like, it's a multi-source BFS, right? It's a multi-source. We have multiple fire points, and each of the fire point will be spreading, so we can do a multi-source BFS to calculate Tij. How can we calculate Mij? It's a single source BFS. We have a source, we have destinations, we'll find the minimum distance, so it's a single source BFS. So will shortest time taken, yes. Yes, shortest time taken, yes, definitely shortest time taken, right? So we'll use BFS. We'll calculate, for first of all we'll calculate Tij by using a multi-source BFS from each of the fire points, and calculate what is the time taken for each cell to reach the fire to that cell in shortest time. Similarly, Mij will be what is the time taken by the man to reach the corresponding cell. We can do a BFS for that in shortest time, and after that we can do this comparison for all the cells at the sites, right? MRC less than TRC. So that should be the solution, right? In that case the man can escape, otherwise he cannot. Let me know if anyone has any doubts with this, and we'll go to the code directly. Okay, so code is somehow not working. Refresh. Anyone has any doubts with this? Yeah. So we will write a method called let's call it T vector in T, and here we have vector int m, right? Vector int T, vector int m. So let's do one thing. So void fire BFS, let's call it fire BFS, right? Fire BFS. So what we'll do is, and we'll initialize here everything. So T equals to vector int vector int n vector int m, vector int m, and initially let's initialize them with something called int max, right? So similarly m will be a similar thing, so let's just copy this thing, and m is also initialized with the same thing. So fire BFS, what we'll do is we'll take a q, int q, for int, and let's also maintain the n and m here, right? So int n and m, or let's call it R and C, number of rows and number of columns. So R equals to n, C equals to m. Okay. For int I equals to Java में कोई love session. Again, the idea is not to use, like, not to be focused towards the language, right? The idea is to learn how to solve the problem, how to think about the problem, how to solve the problem. अगर जावा आता है, जावा का syntax is very similar to C++. I don't really believe you should have some problem. Again, vector जैसा है, vector will be equivalent to array list in Java. Q already exist करता है जावा में, right? So it's same thing, only a few things here and there, right? So I don't think you should have any problem understanding the code. I plus plus. Yes, this should be m, my bad. So less than plus plus for int j equals to 0, j less than c, j plus plus. If, and we have the grid, so let's pass the grid here. If grid ij equals to fire, in that case we'll add them to the queue. Q dot add, q dot push, I think is there, q dot push. It should be a pair int. It should be storing two values, row and column. So int pair int. Again, Java में अगर करना है तो you can use a structure, you can use a class called pair, and use that object, right? So something like that. So ij and t of ij equals to 0. Okay. So while not, q dot empty pair int b equals to q dot top, q dot front it should be, I think, q dot front, q dot front and q dot pop, right? Now what we'll do is we'll go to the adjacent values. Let's maintain that adjacent values here. So vector int graph क्या आ रहे हैं, graph is very important यार, skip मत करो. 1 minus 1 0 0 and vector int dy. It's very easy to write the code for graph problems, right? Like you just have to write it once and then you remember. So if you see like matrix bfs vagera, it's very simple to write once you do it once, right? So for int I equals to 0, I less than 4, I plus plus, int next row equals to v dot first plus dxi, int next column equals to v dot second plus line 23, what did I do? Dot remove, okay, thank you. So v dot second plus dyi, right? We're going again, like we can write it manually as well, like I minus 1, v dot first minus 1, v dot second. Like there are 4 cells, right? I r minus 1 c, r c minus 1, r c plus 1, r plus 1 c, 4 cells. So instead of that, you can maintain these two vectors. This will represent row plus 1 column plus 0, row minus 1 column plus 0, row plus 0 column plus 1, row plus 0 column minus 1, right? Next row and next column. And if it is a valid, right? So also let's maintain this called valid. Bool is valid, a row and a column. So if row is greater than 0 and row is less than greater than equal to 0 and row is less than r and column is greater than equal to 0 and column is less than r c, then will return true, otherwise will return false. So if is valid, next row, next column, and right, and the distance, right? So and m, what is the t, and t of next row, next column is greater than t of v dot first, v dot second, the current cell plus 1. In that case we should push it into the queue. So q dot push next row, next column, and t of next row, next column will be equals to this one, right? T of this plus 1. So we have calculated the t this we have done this bfs. Again we'll copy this, and similar thing we'll do for the m as well. So fire bfs, let's call it man bfs, and q of ij equals to m, right? So for man it should be m. Yes, so it is m. So qij, and we'll make mij to be 0. Yeah. So dxi is valid this, and m of next row next column is greater than m of this thing. So q dot push, and m of next row next column is equals to m of v dot first v dot second plus 1. So that should be it. That should be the entire set of changes, right? Man, for man bfs, c grade of ij, m of ij equals to 0, and yeah, equals to m, and dx, and will then do the bfs. Okay, so let's do the fire bfs, and after that we'll do the man bfs as well, man bfs. Now the task is just to see if there is a cell, one of the corner cells. So for int I equals to 0, I less than n, I plus plus, right? So grid I0. So if t of I0 is greater than m of I0, return true. Similarly, if t of I m minus 1 is greater than m of I m minus 1, return true. So we have done both the rows. We have traveled across both the rows. Now we'll go for the columns. So I equals to 0, I less than m, I plus plus, t of 0 I is greater than m of 0 I, or t of n minus 1 I is greater than m of n minus 1 I. So we are done with all the four sides. Uh, Otherwise it is not possible, so we'll just return false. So that should be the code, right? Let's try to run this. Compilation error, fire bfs. Okay, we have to pass the grid, my bad. So we have to pass the grid here, grid and grid. Let's run this. Yes, so we are getting yes and yes. So let's submit this. Let's hope that it works. Yeah, this is working, right? So this is the code. Again, pretty simple. What you had to do is, for the fire you will independently find what is the time at which the fire reaches each of the cells. Similarly, for the man you will also independently find what is the time for the man to reach each of the cells, and then you will check if for the man can escape from one of the four sides, right? So for each of the side, whether the time that taken by the man to reach that, the shortest time taken by the man to reach that cell is less than that of the fire, in that case the man can escape, right? So pretty simple. You just had to do two bfs, and that should have done it. So let me know if you have any doubts with this. Otherwise we are done. Anyone has any doubts with this? In the content both bfs together and it passed. Yeah, you can do both the bfs together as well. This is simpler to understand, but yeah, like you can do both the bfs parallelly as well, and that should also work, right? Yeah, definitely. Just to make this simpler to understand, I have done it like this, right? Separated into sets and Okay, so I hope there is no one has any questions. In that case, rat in maze isn't that, if I'm not wrong, that's a backtracking problem, right? So that's, I think that's a different problem. Uh, like again, what you're trying to solve, if you're trying to solve all possible paths, then it's the backtracking. Otherwise, if you're just trying to find one path, then you can do a BFS. So yeah, that's there. But uh, again, like this is called a shortest path question, right? Shortest path in a graph, or in a matrix. You are given a matrix, you have some people or you have a person standing somewhere, and you want to calculate the shortest path to all the cells from this person. That is basically this question, right? So like we are using BFS for this, and you can use Dijkstra as well if the graph is weighted or if the grid is weighted. Okay, so I think no one has any questions, so we'll call it a day. Thank you guys for joining in, and I'll be seeing you next Sunday. Bye. Good night.